Okay, so we finished talking about kinematics and the kinematic equations and the big three. All right, how they each, one doesn't have time, the other one doesn't have velocity, the other one doesn't have displacement, whatever. So you should have a sheet on you called Physics, Chapter 2, Example Problems. Let me get this. I can't read this. All right, so the first one, there's three. Example 1, 2, and 3. So the first one, it says, car starts at rest. Now, if you feel more comfortable doing it this way and writing out all of your givens, fine. If you feel more comfortable underlining certain parts and then writing the variable next to it, fine. But you need to do something, okay? Do not just start picking out equations and trying to put numbers in right from the problem. You have to find some way that you want to identify what things are. So first it says a car starts from rest. Now the word rest is very important. If something is at rest, it means the initial velocity is equal to 0. Let's go to example 1. And it says it accelerates uniformly over a time of 5.21 seconds. And it says for a distance of 110 meters. Okay? Now, this is where the wording gets a little maybe skewed. We don't have distance in our problems or in our equations, but we do have displacement. So if we have a car, you love the car, and it's going this way, starts at rest, okay, accelerates over here, travels a distance of 110 meters, well, we could say that that displacement is positive 110 meters, right? So it goes in this direction, which is the positive direction, positive x direction, that's why we have the plus, and it's 110 meters. Right? So we're going to label that as the displacement x. Just checking this up there real quick. Okay, now I talked about in another video about my Esmond rule about these kind of papers that are handed out. So the 110 meters does not show that the 0 is significant. A lot of times I just forget to put the decimal point on the paper. So it should be like 110 with a decimal point. If that's the case, then we're going to say it's 3 significant figures. I know this is going to aggravate some people. When I'm back, it will make more sense. Let's just put it that way. But zeros on worksheets handed out that I made, you could say they're good. All right? All right, so we have VITX, and we are looking for, it says, determine the acceleration of the car, A, like this. So VITX and A, if you look through the equations, you'll identify the third equation as the correct one to use. We cannot use the other two because they don't even have VF in them. I'm sorry. We can't use the other ones because they do have VF in them. So you notice over here, we're not looking for it and we don't have it, we can't use it. All right? The initial velocity is 0. 0 times t is just 0. This is a step that I normally would not do. And then we're solving for A. So it depends how you want to do this. You can divide the entire thing like this. I generally do not do that, and then you just have A equals this. So I like to multiply by 2 first, but either way works. I don't like having fractions in the denominator. I think it just looks bad. People tend to mess up over the years. So it would be 2x divided by t squared equals A. Now in class I would never do that, okay? I would never have that A over on the right hand side. But leave it there, solve for it, and then you could always flip it if you want. I'm putting a lot of extra steps that I wouldn't normally do. So it's 2 times x, which is 110, divided by t squared. And the answer is positive. Now this is where I'm going to get caught. because on my paper I only left it as 2 significant figures. So let's do the calculation. 2 times 110 is 220 divided by 5.21 squared. 8.10. I'm off the screen, am I not? So this answer is 8.10. Is that better? Is this off the screen? This over here is not? Oh, is this over here then? Okay. What happened? All right, so we're solving for acceleration. When we look at the units, 2 times this with the meters would just be meters on top. Seconds, we're squaring it, would be seconds squared. And acceleration is always measured in seconds squared, so that works if we check the units. Now, the acceleration has to be in the positive direction if we're speeding this car up, or if it's even going to move in the positive x direction. That's why we have this right here. So the positive is required, the vector signs are required, and you have to make sure you get the right significant figures in units. Right? So that's one example. Right? And that's what you'll be doing for every single one. So as far as the steps go, we need to write down the original equation. We don't need to write the second part. We need to solve for it, and then we need to put the numbers in. All right, 1, 2, 3 with the correct answer and significant figures.